really glad to be here today and pleased to be talking about NIAB. I retired from NIAB at the end of September, but I'm still associated with it. I still do different things with them. And at the beginning of October, I was awarded an honorary professorship here at the university. So that keeps my connection with the plant sciences department in particular, but with the university in general. So I want to talk to you about NIAB, and in talking about NIAB, addressing some of the points that Amanda made. So can I have the next slide? So NIAB is 102 at the moment. So this man, Lawrence Weaver, was very important to the history of NIAB. So after the First World War, Lawrence was appointed controller of supplies at the Board of Agriculture and Fisheries. And without his efforts, NIAB would never have come into existence. So the next slide. So that's him, that's a photograph of him. And his portrait is at NIAB, and you'll see him feature in a few other slides as we go forward. Next slide. So we have to talk before about NIAB. Before we talk about NIAB, we have to talk about why NIAB came into existence. So the Plant Breeding Institute was established in 1912 as part of the Department of Agriculture at the University of Cambridge. Now, the University of Cambridge no longer has a Department of Agriculture. I believe it closed in the 70s. And the director of the Plant Breeding Institute was a renowned wheat breeder, and wheat breeders will recognize these varieties. They brought in resistance to yellow rust disease, which still is a problem. And the first work of PBI was to improve the existing wheat varieties. And one of the varieties they produced, which was called Yeoman, stayed recommended to farmers for a good 30 odd years. So the work PBI was instrumental in improving British agriculture, and not just British agriculture, because of course the wheat that they produce can go to other countries, and that resistance can be crossed with other wheats so that it can be grown in those countries too. Next slide. But supplies of good quality cereal seed from the PBI were scarce. So the PBI was making these crosses, producing some seed. You know, if you imagine you take two plants, cross them, you get a handful of seed. And to multiply that seed up, what was happening was that commercial companies, seed merchants, were taking that seed, planting it, multiplying it, and renaming it. And some of you may know, if you do that and you don't do it in the right way, you risk introducing other diseases. Farmers were confused about the naming. And so Lawrence Weaver went to the government and said, what you need is a technical institute. You need an institute that's facing industry. So it's got to respond to what the industry needs, not just what the research institute is putting out. And so the National Institute of Agricultural Botany was founded as a charitable trust, and the slogan it was founded under was better seeds, better crops. Next slide. And that declaration of trust had aims which are as relevant today as they were 100 years ago. So it was to promote the improvement of existing variety of crops in the UK, promote the improvement of methods of husbandry for the benefits of agriculture and horticulture, because of course it's one thing to have a good variety, but if you don't grow it properly, you won't realise all the benefits of it. And also to encourage the discovery of, investigating and making known the nature and merits of treatments, inventions, improvements and processes which may benefit the industry. Next slide. So on the 14th of October 1921, King George V and Queen Mary came to officially open the new institute in Cambridge, and they planted a mulberry tree. They planted two trees actually, one each. She planted the one at the front, and if you go up the Huntingdon Road out towards Huntingdon, as you go to Eddington, towards Eddington, you'll see that building on the right hand side. we moved out last year to new facilities, and it's actually being converted into flats at the moment. So next slide. And then we've had an association, NIAB's had an association with the royal family since that day. And in July 2019, Her Majesty Queen Elizabeth II came to celebrate 100 years of NIAB. And she too planted a tree. And that story, some of you might remember, was all over the front pages of the newspapers in the UK. We asked the palace, will she plant a tree? And they said no. She won't do that. She will stand by while you plant a tree. And but when we told her that's what was going to happen, and they kept saying to me, do remind her that she doesn't have to plant the tree, she just said, I'm still perfectly capable of planting a tree. And she took the spade from our chairman, Jim Godfrey, and she shoveled the soil in herself. Yeah, exactly. So the other two people, so there's me, and then the other two people are the man standing behind the tree is Lawrence Weaver, the original Lawrence Weaver's grandson, who's also called Lawrence Weaver, and his sister. So there are 4 grandchildren. Lawrence is a nutritionist and used to work at something called the Dunn Institute, which I think was in Scotland or north of England. One of them is a botanical illustrator. The other one is married to a farmer. And the fourth one, I couldn't really work out what the connection was, is a furniture designer. And I thought, oh, well, you know, most of them have done sort of science and followed their grandfather. But we invited them to NIAB, and when they came into the room, they recognized some of the furniture in the boardroom, so when NIAB was, that building that you saw was originally built, Lawrence Weaver commissioned a man called Percy Holden, who designed furniture for NIAB, and also some of which they had in their home. So they recognized it, and so that was the connection. So the next slide. And because, well, not just because the Queen came, but because we had celebrating 100 years, we put in place, I have to read it off because I can't remember them all, but there were a few key dates that were really, really important to NIAB. So in the 1940s, NIAB launched the first recommended list for farmers. So if you imagine, up until then, it was a salesman just going on to farm and saying, do you want some of this, mate? You know, this is really good stuff. And there was no criteria by which a farmer could decide if it was really good or not. So NIAB produced these recommended lists, not just of wheat, but also of barley, oilseed rape, and many, many other species. And in 1961, it brought vegetables into that. So there were vegetable recommended lists. And then in the 1960s, the UK joined the International Plant Breeders' Rights system, which has certain criteria that a plant breeder needs to fulfill in order to put a variety on the market and collect royalties on that variety. And NIAB was commissioned by the Ministry of Agriculture to do that work. And at this point, although NIAB was an independent charity, it was still supported 99% by the government. And then in the 1970s, when the UK joined the European community, the system of plant breeders' rights was interwoven with the way the EU process worked. And that still hasn't been unravelled as one of my ongoing concerns for the plant breeding industry is that. So as time moved on, the NIAB started to use different technologies, biochemical techniques. DNA techniques are still controversial because what the farmer is interested in is not what's inside the DNA, but the phenotype, so what the plant looks like. And so NIAB's carried on doing that. Now, if you can imagine also that as all of this was evolving around NIAB, there were other organisations that were evolving to help farmers too. There was an organisation called ADAS, the Agricultural Development and Advisory Service, which is well known for the chap who went down the farm path with his pencil in his pocket and his book, and he would tell you what to grow, what chemicals you could use, you know, what was suitable for your field. And so that organisation was really big and really important in the UK. And in every sector, there were people making contributions to farming, which were funded by government. And then in the 1990s, some of you will remember Mrs. Thatcher, Margaret Thatcher. During her time, they determined that any research which was near market needed to be paid for by the market. And so NIAB, it was decided that NIAB was a sort of hybrid case, and NIAB became a not-for-profit. ADAS was privatised, the Plant Breeding Institute was sold to Unilever, but NIAB retained this status of a not-for-profit. So I suppose a recognition that this sort of translational research was still needed. So in 2005, the plant breeders started to realise that there was no new material coming through from the PBI anymore, and they supported NIAB and the John Innes Centre in persuading the government to support research to develop new material coming from wheat particularly. And so then in about 2009, NIAB merged with an organisation called the Arable Group, which was some of the vestiges of the advisory service. So at this point, NIAB knew everything, NIAB covered everything from the plant variety development through to on-farm. In 2013, there was a change of administration at the university, or a little bit before that, and they realised that there was some research going on potatoes at the university farm, but it wasn't associated with the plant science department. And it was the more practical, applied sort of research that NIAB did. So at that point, the Cambridge University Farm, as it's called, the Potato Research Group, joined NIAB, and that was the start of our closer association. You know, we always joke, NIAB's been there 100 years, university's been there 800, 100 is, you know, nothing. In 2016, NIAB merged with East Malling Research, which is a fruit research institute in Kent. And in 2019, new facilities were developed, and the alliance with Cambridge University, the Crop Science Centre, which I'll say a little bit more about. So that was just a bit of the potted history. So the next slide. Well, this next slide. So I thought you might enjoy seeing the trials teams. So the trials teams, I would imagine that would be in the 30s or 40s. You can see they're all men, they've all got their notebooks, they're all wearing ties, and this is the trials teams today. So they're the people who actually go out and put the material into the field and evaluate them. And you can see there are a lot of women, they're much more casually dressed, and a real contrast, but essentially they're doing the same kind of work that those people did. So the next slide. So NIAB is still the UK government's main technical contract for plant variety testing, which means NIAB provides technical and policy advice and UK representation in international bodies. So that's a part of what NIAB does. And to talk about it in terms of turnover, that's about 10% of the income that NIAB has today, but it is the core function of NIAB, and it remains the same. The reason it's reduced is partly because the number of species that this testing is relevant to just changed, and also the way that it's done. A lot more work is done by the industry itself. So the next slide. So yeah, NIAB became a not-for-profit, and today it works on multiple crops, genetics and agronomy, it does research, and it carries out services to the industry. So the next slide. So this pretty much sums up what I've just said. The genetic research capabilities, the integration with the agronomy research, the fruit, the potatoes, and then I suppose the latest thing was the crop protection. So the green book, it's like the Bible for agronomists. These are the chemicals you can use, and these are the circumstances in which you can use them. NIAB took that on. Okay, next slide. And the next. So there are around 400 staff work at NIAB, interested in genotype, the environment, and the management, which is absolutely critical. It's one thing, creating a plant, but you've got to know how to grow it. And NIAB has very strong agri-food chain links with PepsiCo, Nestle, the big organisations like that, as well as with small plant breeders and individual farmers. Next. And the next. So the breeding and pre-breeding teams operate across a wide range of crops. Possibly the most important are still wheat and strawberries, since we took over East Malling Research. So East Malling Research, there's a variety called Malling Centenary, and you'll start to see now all of the varieties coming out of East Malling called Malling. Malling Centenary is one of the most popular varieties, and you'll find it in your supermarkets early in the year. And we just have a new one called Malling Ace, which is coming out around the same time as Wimbledon, which I think everyone can make the connection. And the next. So we carry out field scale research, which is quite different to laboratory research, as well as laboratory research, field scale research. And that's pretty unique. In the UK only. There is a subsidiary in Spain now, and we have an alliance with an institute in Spain that does similar things. But essentially, that kind of work is very local. You know, every farm is an experiment, every field is different, and so we there have to focus on the UK in that respect. But the genetics travels across many countries. So the next slide. We have a farmer membership, and the membership pay a subscription to be members. They receive a suite of technical booklets. They have meetings. They have a telephone hotline to agronomists. And I suppose for me, one of the most important is that they guide the research that we have, which is supported by government. So, you know, it's no good working on something that the industry isn't interested in. And these farmers, it's not just farmers, it's also industry, also the associated industry, so the millers, the people who distribute seed and chemicals to farmers are also members. Next, and you can see, sorry, before we go, you can see that NIAB's located, these field trial sites are located all around the east of the country. You can pretty much divide the UK into two, the sort of arable big farms here, and on this side you find more of the animals. You know, you don't, well, I mean, it's changing a little bit because people are starting to realise that there's something good about a rotation that has animals in it and the manure going back into the land. But I know when my kids were growing up, you hardly saw a cow in East Anglia. So NIAB is based in Cambridge, so there are about 250 people in Cambridge, about 100 in Kent, and the rest are distributed in these trial centres throughout the country. Next. So just to say some of the things that NIAB's working on in wheat, we're part of, one of the most important things I think is an international network working on nitrogen optimization in cereals, because we all know that the production of nitrogen fertilizers is one of the biggest producers of greenhouse gases, of CO2, and to try to reduce that by having plants which can grow well with less nitrogen. is a really important trait. We also work quite a lot on rice. This is part of our alliance with the plant science department here. And it's something that just arose because I always say when you get DNA in the test tube, it all looks the same. You can work on wheat, you can work on rice, and that's a program that's been accelerating over the last few years. Next slide. One of the most interesting stories is super wheat. So we had people from Country File came to visit us. So Tom Heap came to visit, and we were calling this synthetic wheat because what we'd done was go back to the originators of the wheat plant. So wheat is a hybrid of these two grasses, goat grass and what's essentially durum wheat. And goat grass is found in the Fertile Crescent around Iran and Iraq. And all of the wheat all over the world came from one cross. So one of the things that NIAB wanted to do was to increase the diversity available to the plant breeder, make that cross again. It's really difficult, as you can imagine, it happened in nature once, and to do it in the laboratory and to then grow out a range of these plants. And we were calling it synthetic wheat. And Tom Heap came and said, you can't call it synthetic. People won't like it. And he suggested we call it super wheat because it would have these new characteristics. So the idea is you're introducing new disease resistances and just variability for a wide range of characteristics. So the next slide. So this is Elizabeth Stocktail, NIAB's soil expert. So with the membership, she's been studying conservation farming. So this is sort of at the other end of the spectrum from the genetics, comparing to what the standard growers are doing. And we know, regenerative farming, agroecology, they're just fashionable terms. Elizabeth's been working with farmers to make these changes for several years now. And she's also been looking at a number of things. We know that glyphosate's unpopular, and she's been looking at whether there are ways you can control weeds through cultivation if and when glyphosate is banned. So next. Another interesting development has been the use of crowdsourcing. So I think if you go to the next slide. So individual farmers can record whether they have a particular disease in their crop. And so then we can see, when we do that throughout the whole country, we can see where the disease is moving. And we can then warn farmers who are close by, and we can see it coming. Look, these guys near you have got it. They can all log on and see what the status of different diseases is. And they can also, that's also really important, because when a plant breeder introduces a new variety, they'll say, for instance, this is resistant to yellow rust, but that resistance can be broken down by the fungus. The fungus mutates, and suddenly the plant is susceptible to the disease instead of resistant. And it's really important that the farmer tells us this plant, it seems to be, it should be resistant, and it isn't. And so we can then say, send in a sample, we'll check that you've got the right plant and the right disease, and then we can tell the breeder, your variety is broken down. Next slide. So you see that's, this is one of the early ones we have record from all over the country, and it was great. We didn't know if it was going to work. Somebody set it up at sort of 5:30 on Friday night and checked it on Saturday morning, and we'd had 150 farmers respond. So it's great. I think what technology has done for farming in things like this has been really important. There are lots of other technologies that we could talk about, but just simply in sharing information, and not just in the UK. It's been really important. Next. So let's just say a few words about the Crop Science Centre. So the Crop Science Centre is a partnership between NIAB and the University of Cambridge, and the idea is to provide global leadership in crop science. It took quite a long time for us to get this off the floor. I was working with Professor Sir David Bolcombe, who was the head of of Department of Plant Science at the time. And I think it was 2013 we started this. And then in 2020, a professor of crop science was hired, Giles Oldroyd, and Giles is located in a new building based at NIAB, and he now has a team of about 20 people there who are interacting with NIAB. And of course, he works on nitrogen fixation. So one of his goals is to, you probably know that peas and beans fix their own nitrogen, wheat and rice don't. So one of Giles's objectives is to move that characteristic from legumes into cereals so that we can avoid nitrogen fertilizers. His colleague Uta Paskovsky works on phosphate capture from the microbes that are associated with plant roots. And they both desperately want to get their stuff out into the field and tested. And so that's why the alliance with NIAB's been so important. Next slide. So the Crop Science Centre then brings together, some of you may, well, I'm sure a lot of you know, the Sainsbury Laboratory, so on the left-hand side, which is at the Botanic Gardens, the Plant Sciences Department, and NIAB. And this is how we've chosen to illustrate NIAB, because NIAB's out there. And I hope that one day you'll get an opportunity. There are several open days at NIAB, and I'm sure you'll get an opportunity to visit. So it brings together these, the Sainsbury Laboratory is associated with the Plant Science Department, and Giles, before he became Professor of Crop Science, was located at the Sainsbury Laboratory. Next slide. So by tackling photosynthesis, so how plants capture carbon and therefore have increase the yield that they have, nutrient uptake that I already mentioned, and diseases and pests, the aim is to drive a revolution in agriculture through this transformative science. And of course, this doesn't just mean working with NIAB and Cambridge University, it's a global effort. Next slide. And because it's a global effort, much of Giles's work is funded by the Bill and Melinda Gates Foundation, and they are very enthusiastic about the Crop Science Centre and have been very supportive, as have the UK government, the Department for International Development, because as you probably know, the focus of the Gates research is sub-Saharan Africa, where they see a problem. They have different problems to us in that, you know, we certainly use too much nitrogen. In parts of sub-Saharan Africa, they can't access chemicals, they can't access nitrogen. So if Giles can create cereals that fix nitrogen, it solves that problem too. So next slide. And the people who work in the Crop Science Centre, all of us are committed to equity in agriculture. So there are farmers who farm like this. The next slide. As well as farmers who, you know, you farm as you've seen them farm here, or in North America, you know, in Canada, you see those huge swathes of combines going across the field. They're all farmers. They all have different but similar challenges. So we started to think about what the priorities for research might be in the next 100 years. And we know that agriculture can provide solutions, and we've all been thinking about climate change recently with COP26, and at its simplest, photosynthesis captures carbon and soils can hold it in there. Soils can sequester carbon. Nutrition is obviously another important aspect of food production, and diet diversity, not just for us here. We have an amazingly diverse diet here in the UK because we can either grow or access most things. That's not the same in other places. And waste, the efficient use of resources, it starts when you put that seed into the ground. You know, it used to be the case, and it still is the case, that when farmers put nitrogen on the field, they just essentially broadcast it. You've seen these hopper things with white coming out the back. There's now much more emphasis on precision agriculture, where you're fertilizing exactly where you need it. You're spraying the chemical exactly where you need it. And weed killing is being revolutionized by people using lasers, using heat, using mechanical processes rather than agricultural chemicals. I think farmers have always realized the importance of biodiversity, but I think they're realizing it even more now, because when they can't use chemicals, we know that the richness of what is found in the soil, the microbes that are found in the soil, can help to combat diseases. We've just got to get the balance right. And there are many, many other reasons why biodiversity is important to agriculture. Next. So what could we do in the next few years? Because I've never been, I'm not Lawrence Weaver, I'm not a real visionary. So I'm thinking what might be the things that NIAB, the Crop Science Centre, could tackle in the next few years. And these are some of the things that we've thought about. So combining plant genetics and agronomy and using big data. So not just 150 farmers, but all of the farmers at giving information about what they're doing. Weed control is an important thing. There's a weed called blackgrass that appears mainly in the UK, mainly in wheat, mainly in this area. And it's mainly controlled by agricultural chemicals, by glyphosate. But even then you get resistance to the herbicides. So, and because it's mainly a UK problem, the big agricultural chemical companies aren't going to develop a weed killer just for the UK. So what other processes can we use to control blackgrass in wheat? And that's one of the immediate problems that we've been looking at. And before we manage to fix nitrogen in a plant, maybe we can improve the efficiency with which nitrogen is used. So there are a number of things that we think we can tackle. Sorry, next slide. So I think Lawrence Weaver would have been smiling if he saw what NIAB had become after 100 years. And it's been great to make that connection with his family and also with the families of the other main donors, the main people who started NIAB, the philanthropists who put up their own money and went to government and said, match this funding, which is what often happens in this space. Government will fund basic research, but when it comes to that, is this really going to benefit industry? They like to see industry putting in some funding. And so Frederick Hyam, there's still a big farming operation quite close to here, and the Guinness family were also big contributors to NIAB in the beginning. So I was the first woman director of NIAB, and I found in the archives when they were looking for the first director, a woman wrote to them and said, was it possible for a woman to apply for this position of director? So they had a meeting of the board and they replied, they saw no reason why a woman should not apply. so even then they were quite kind of open. So the next slide. Just wanted to end with some more pictures of Her Majesty the Queen. I think she thoroughly enjoyed her visit. We gave her a bouquet with flowers, but obviously with some wheat in it as well. And she asked to spend a bit of time on her own, without the entourage, without the press, just talking to our wheat breeder. And she was asking specific questions of Phil. She was asking about the Maris varieties, which were actually the ones that were created at PBI were always called Maris something. And she was very interested in the work that he was doing. So I think that was a really, really great finish to the day and a great way to celebrate the centenary. So thank you.